In this lesson, we'll look at the components used in the generation of hydraulic power. We'll start with the hydraulic source, the reservoirs, and then look at the engine-driven pumps, or EDPs. We'll cover the backup components, such as the electric pumps and the power transfer units, PTU, followed by the servo control selector valves and the ram air turbine, RAT. The hand pump and fire shut-off valves also play a part in hydraulic generation, but, unlike the other components, are not displayed on the ECAM hydraulic page. Each of the three hydraulic systems is supplied with its own reservoir. As we saw before, it is not possible for fluid to be routed from one system to another. All reservoirs are automatically pressurized by air pressure from the pneumatic system in order to avoid pump cavitation. As you can see from the ECAM, there are 4 engine-driven pumps, 2 for each engine, which supply the hydraulic systems. Point with the mouse to the name of the system which is pressurized by 2 engine-driven pumps. The green system is pressurized by engine-driven pump 1 and 2. Engine 1 drives 1 blue and 1 green pump. Engine 2 drives 1 green and 1 yellow pump. The normal operating pressure for each system is approximately 3000 psi. There are 2 identical electric pumps for the green system, although only one is shown on the ECAM. Their main purpose is to assist one green engine-driven pump when the other is inoperative. They can also be used for system test. Delivery flow of the electric pumps is about 30% of the flow of an engine-driven pump. The yellow system electric pump can be used when the yellow system is not pressurized to pressurize and operate the cargo doors or pressurize the brake accumulators. The yellow electric pump is not shown on the ECAM. The PTU can be used in flight if a pump fails in the blue or yellow systems. Power, not fluid, is transferred from the green to the blue or yellow systems. Only one PTU can be operated at a time. PTU operation in flight is possible only if 2 green engine-driven pumps or 1 green engine-driven pump and both electric pumps are operating. The servo control selector valves are used to isolate the primary flight controls for each hydraulic system. Now let's look at the final 3 components of the hydraulic system. In case of yellow hydraulic system failure or dual engine flameout, the RAT supplies a maximum pressure of 2800 psi for emergency hydraulic power. The RAT consists of a self-regulating pump driven by a constant speed propeller. Once the RAT is extended into the airstream, an in-flight retraction is impossible. A fire shut-off valve is used to isolate the engine-driven pump from its reservoir. Although the fire shut-off valves are not shown on the ECAM, use the ECAM to monitor the yellow system when an engine 2 fire handle is pulled. Pull the corresponding fire handle to close the fire shut-off valve. The valves close, isolating the hydraulic fluid from the burning engine. As a result, the pressure falls in the corresponding pump. Note, in case of yellow reservoir low level, the fire shut-off valve will automatically close to keep a minimum fluid quantity for RAT operation. On ground, with no systems pressurized, a hand pump may be used to pressurize part of the yellow system in order to operate the main cargo doors. Like the fire shut-off valve, the hand pump is not displayed on the ECAM. Here is a summary of the 3 hydraulic systems and their components. Study it, and when you're ready, select the Forward icon to answer some quiz questions.